Does anybody remember this stuff right here? What is this symbol? Anybody remember the symbol? Sigma, what does it mean? Add up. What is this? Your index? Yeah. What is this? Is this where you start? Yeah. What is this?
Where you stop.
Where you stop. Where you end. So this, everywhere like this I want to start by putting 1. So this really means 1 plus, I'm going to count out my ones. 2, 3, 4, 5. 1 plus 2 plus 3 plus 4 plus 5 plus 6. That's easy enough, right? And then from there, I can actually add them up and get the sum, but I don't really care about that. I care about expanding it right now. Right? This next one looks a little bit more confusing. It's the sum of k equals 1 to n. But here I have 1 over n, k squared plus 1. Well, what I can do is I can pull that 1 over n out like a constant because it has nothing to do with k. Right? It has nothing to do with k, so I can pull it out, 1 over n. That leaves me the sum of k equals 1 to n of k squared plus 1. Everybody okay with that? That 1 over n has nothing to do with the k, so I can pull it out like a constant. I'm going to treat it like a constant. This really equals 1 over n times, well, I'm going to start at 1. 1 squared plus 1, right? Plus 2 squared plus 1, plus 3 squared plus 1, plus, I got to get to n, right? So this becomes n squared plus 1. And you're done. You can calculate all those numbers, but really I'm more worried about this expansion right now. But if n is 2, then we would stop right here. I'm establishing a pattern. To be able to use the ellipse like this, you have to establish a pattern in front, then you can do the n. What's the term in front of this? N minus 1 squared plus 1. Does that make sense? 2, actually. 3 is just overkill, but I'd rather do 3. All right, how about this one? Does anything in here not have an I on it? So I could treat delta x all by itself, right? Just like I did the 1 over n here. And I'm going to multiply it by f of x sub 1 plus f of x sub 2 plus plus f of x to the n minus 1 plus f of x to the n. Done. This is all about expanding. All about expanding. All about expanding. Because what we're going to end up doing is we're going to use this idea to find area. Because when we did that poster, didn't all the yellow's formulas have a sigma in it? So we're now going to have to start using sigma so we can actually find area. But Sean, I want to ask you something. Did you use plus signs? What did you use? Don't do that. Comma is making a list. This is a summation, so you have to have the pluses. Okay? Other than that, the only thing I saw is people getting started on this. Guys, you're going to get a lot of practice started on this. A lot. A lot. I'm going to write some things down. Normally, this is normally not that heavy of a class on notes. This is more of let's practice a whole bunch of calculations. However, you cannot do calculations without the notes I'm about to give you. All right, here's some basic summation formulas. The proofs on why this is true is in your book. You can look it up at home. I am not going to go over it. So, the sum, when I equals 1 to n of c, and c is just any constant, is c times n, where c is a constant. Okay. You need to get those written down. I would say go ahead and commit them to memory, but so much you end up getting most of them to memory. Very carefully. Okay. It's kind of like just a funky E. I just kind of start with a line down and just kind of go like that. Then like a line up. Nobody's like, quote Hannah Montana, nobody's perfect. Right? A lot of people that have ever seen. You got a song about it, buddy. Thank you, Chelsea. I already knew that. Buddy's paragraph. The song is good. Okay. So here's a basic idea. If I want to start with something very basic. I have a triangle. We know how to find the area of this, but let's just use this because this is a trivial example of the basic idea how this is originally found. If I inscribe a circle, that's horrible. Use your imagination, that is a circle. Say this was a shape we didn't know, but we do know how to find the area of a circle. I can find the area of the circle, right? In this case, this inscribed circle, I would call it a lower bound. A lower bound. Because I know the area of that shape. I want to say, even though it's a triangle, it's some shape, because this really represents any shape. Right? We know that that's going to be a lower bound, and we know the area is going to be bigger than that, right? But then I can go ahead and take another circle and circumscribe it. I can circumscribe it. That's not spelled right, but a circumscribe is our lower bound. I mean our upper bound. What am I thinking? Shut up. Ask Siri. So the inscribed circle would give us a lower bound, right? And the circumscribed circle gives us the upper bound. Somewhere between those two would be the real area, right? Somewhere between those two is the true area. Would you all agree? if I say, no, let's not do that. Okay. If I said n was the side of my figure, what would happen to my upper and lower bound if instead, if it was approaching 3, let's say n approached 10? Would it become a little bit more accurate? Would these circles start drawing together on a decagon? All right? Would it start drawing together? What about if I have a 100-side figure? Would they start getting closer to the actual? Now all of a sudden that lower bound and upper bound, they're going to be really close, right? But this still guarantees that somewhere in between there. What if I say this? Then that's the area, right? That's basically the premise of what we're going to work with. Yes, ma'am. Is the number of sides of the shape. Yeah, it's the number of sides of the shape. It's the one that we're sandwiching between those two circles. So that's the basic idea on how to find. Now, when you guys did your project, did anybody even remotely think of this? Upper, lower bound? No. But y'all did think of different ideas with different shapes. You had to sum everything up, right? And you did it with different shapes, yes? Well, so one shape is probably the easiest to work with. A rectangle. Square, okay. So a square is a rectangle. But unfortunately, the problem with the square is your height and your width are the same. The rectangle, we can manipulate it. So we're going to do this with rectangles. So you'll get the basic idea of how you can find area of anything, right? So it doesn't even have to be a circle, just any shape that you can find the circle, you can inscribe and circumscribe. Anything that you know how to find the area of. So technically in geometry, you learn to find the area of a pentagon or a 100-side figure. You learn how to find the area. Was it 1/2 perimeter apothem times the apothem?
Yeah.
Y'all didn't remember geometry?
Absolutely.
I already know who most of y'all's teacher were, so I'm okay. I understand. Geometry. That was freshman year? That was freshman year? They ain't no way. They know. All last year I heard them whine. I didn't learn anything in geometry. You know who my teacher was? Isn't that all about, yeah, Chandler, not Chandler. Sean had a big crush. Alright, boys and girls, here we go. I am not going to give you a shape. I'm going to give you a formula. This is Monday morning, right? Not for ours, right? Okay. I'm going to give you a formula, and I'm just going to ask you to simplify it. So we're going to start by simplifying this. We're going to do sigma I equals 1 to n of I plus 1 over n. Oh, this is n squared. All right. Here we go. Here we go. Here we go. This n squared means nothing to me. I'm throwing it on the outside. 1 over n squared. And we do the sum from I equals 1 to n of I plus 1. Right? I just rewrote it. Now, I'm going to break sigma up. If you remember, no, we did not teach this in pre-calc. So this has the same rules as derivatives and integrals. I can break it up to I and the 1. Doing the sum rule, right? So I have 1 over n squared times sum of I equals 1 to n of I plus the sum of I equals 1 to n of 1. How many times do you think I've written sigma in my life?
A few.
A few times, maybe 5 or 6. All right, from here, I have my 1 over n squared. I have a formula for the sum of I when I equals 1 and is bounded by n. That's going to be n times n plus 1 over 2 plus, well, this is a constant, just becomes n. That's where those formulas were that I gave you. Now I have everything in terms of n. And now we simplify. 1 over n squared times, let's see, this is going to be n squared plus n plus 2n over 2. All I did was add fractions and distributed. Right? So this gives me 1 over n squared times n squared plus 3n over 2. This is going to give me 1 plus 3 over 2n. Guys, you're in calculus now. I will not show every step. Everybody understand how I got to where I got to? Yep. Yeah. You sure, Vanessa? I distributed and split. Oh, this should be 1/2, huh? Shame on y'all. I'm still working through it, man. Shame on me. Shame on y'all not catching my error. Because it's going to be n squared over 2, and when I multiply the 1 over n squared, I'll have n squared over 2n squared, and it just becomes 1 over 2. And then 3n over 2n squared just simplifies, the n goes away, but there's still 1 on the bottom. Yep. Okay, here's what we're going to do with this now. I'm going to create a table. I want to know where n, and then the sum of I equals 1 to n of I plus 1 over n squared. I want a table 10, 100, 1,000, 10,000. This is where my calculator is really, really handy, because I now have a formula I can put in the calculator, and this is where my friend, either you can do it in the table, or some of y'all prefer the table, right? Or you can do the such that n equals 10, and then you go back up, add a 0, go back up, add a 0, go back up, add a 0, right? Or you can just let me write it on the board, because I've already done this. 0.65, 0.515, 0.5015, 0.50015. Guys, what am I really doing on this table? What am I really doing? There's a name. What am I doing? There's a calculus name. It's one of the 3 big ideas you learned this year. It's a limit. Didn't y'all learn how to do limits in a table? Did y'all learn how to do a limit in a table?
Oh, I know what it looks like.
A little bit. A little bit, where it's converging to a number. What number is this converging to? 0.5. So if I said, so if I asked you, what is the limit as n approaches infinity of the sum of I equals 1 to n of I plus 1 over n squared, what's your answer? 0.5. 1/2. So if this represented a shape, what would the area be? You just stab in the dark. What would the area be if that represented a shape? 1/2. Now, I'm not worried about units unless they give you units at this point. Right now, this is just an exercise. Guys, it's going to be a lot of algebra, if you can tell. Use your calculator. Your calculator will be your friend on expand. Like when you have to start expanding things. You can expand by hand, or you can expand in the calculator. Are y'all ready to try one? Do y'all have this copied down yet? More is a better question. I see some people still feverishly happy. Jasmine, you good? Nessa, you good? Trey, you good? This is when you start to pay your dues to earn the right to say that you've taken calculus. You have not paid your dues yet. You have to earn the right. I don't care what the schedule says. You have to earn the right to say that you took calculus.
I think.
All right, boys and girls, have at it. Have at it. Let's see, it's 32. Y'all get out of here at 50? 40? Oh, y'all ain't going to get through this problem. Well, y'all might get through this problem. You may get through this problem. Now, I am actually. My quads are really tight right now, especially my left. This is where those formulas come in handy, the I squares and the I and the...
So what are we supposed to be ending up with?
Nope. All I want you to simplify it. So simplify this and then do the table. I'm not worried about the limit. Because once you do the table, you're going to know what the limit is. So give me a table when n equals 10, 100, 1,000, and 10,000. So simplify and then use a table.